Hi, good evening everyone. Please check once audio video is okay or not. Hi Umair, nice to see you. Hi Umair, nice to see you. Yeah, good evening everyone. Please check audio video okay or not. Is audio video okay? Hello. Is audio video okay? Is audio video okay? Yeah, let's see this. Some people are giving answer also. Let's check once. So I will read this problem. The graph shown below 8 edges with integer edge weights. The minimum spanning tree MST is of weight 36 and contains the edges AC, BC, BE, EF, DF. The edge weights of only those edges which are in the MST are given in the figure shown below. The minimum possible sum of weights of all 8 edges of this graph is. Means you want to say the graph shown below having 8 edges. 8 edges are already there. See, let's see. 1, 2, 3, 4, 5, 6, 7, 8. The graph shown below having 8 edges with integer edge weights, that's okay. The minimum spanning tree MST is of weight 36. So MST cost also given and contain the edges. These means what you want to say is the MST of this graph, right? Fine. The MST of this graph, right? Whichever edges MST contain, those edge weights only given. Whatever edge weights you will see, they are the part of the MST. Is having graph which contain 8 edges, right? Which this graph contain 8 edges. Out of those 8 edges, only 5 edges contain weights. 5 edges contain weights. Total how many vertices? 6 vertices, right? MST required 5 edges. So those 5 edges who are part of the MST, those weights are given. Remaining people weights not given. Who are the remaining people? Wherever weights not there, they are the remaining people. So now he is asking, MST weights I given, graph contain how many edges also he mentioned. Now the edge weights which are not there, you have to compute. The edge weights which are not there, you have to find out. Let me write. The edge weights of only those edges which are in the MST are given in the figure shown below. The minimum possible sum of weights of all 8 edges. And one more, these 5 edge weights, whatever is given, right? Edge weight sum also is given. It is already 36. If you want, you can calculate. 9 plus 2 is 11. 11 plus 15 is going to be 11 plus 15, 26. 11 plus 15, 26, plus 4, 30, plus 6, 36. Who are part of the MST, those weights are given, their sum also given. So MST everything fine. But graph contain 8 edges, 3 edges are there who are not part of MST, but they are part of the graph. Those edge weights which, right, to whom edge weights not given, we have to compute. He is asking, some people are asking, sir, Computing it's okay, but should I find out minimum or maximum? The minimum possible sum of weights of all 8 edges of this graph is, right? So all 8 people means these 3 people, missing 3 people plus these 6 people means 36. We have to find out minimum possible sum. Minimum possible sum. Careful. Minimum possible sum. How to solve these kind of problems, right? I think it is a very tricky problem. Listen, it is a very tricky problem. This may come in the GATE exam. It may be very tricky problem. It may come in the GATE exam, right? I want to remind you one time, so I am reminding you. See this one. This problem may come in the exam. I am clearly saying to you, this problem may come in the exam, right? I will try once how to do this. I will try once. Everyone listen. I will try once, right? How much, right? How much easy it is? Let's see. See everyone. See correctly. Whenever this kind of question will come, some edge weights are missing, we have to calculate, right? So what you have to do is just you have to follow this. Please see. A, B, just do this model. B, E, some edge weights are missing, we have to calculate. Then you have to do like this. You have to follow this approach. So whatever MST is given, first to take. Whatever MST is given, first to take. Whatever MST is given, first to take. This is the MST given, so I took. So what is the answer? This is already 9. Right? This is also part of the MST. This is also part of the MST, 2 also given. This is also part of the MST. Just take whatever is given, first to take. Yeah, this is the MST. This is the MST 6. This MST contains 6 vertices, already 5 edges are there. 5 edges are there. So some edge weights we have to find out, missing things. How to do this? Please careful. Some edge weights are missing, we have to calculate. This is the most frequently asked question, right? From the computer science GATE exam, from minimum cost spanning tree. From computer science GATE exam, from algorithm subject, minimum cost spanning tree is coming again and again. In the minimum cost spanning tree, this model may come again and again. So how to do this? MST already given, missing edge weight we have to find out. How to find out I am explaining. Very simple. They are part of the MST, right? So this edge weight I have to find out. Listen. It is already MST. This edge weight I have to find out. What you do is, listen, what you do is, right? Just add this also. Let us assume this also part of MST. Already MST. Let us assume that this also part of MST. Let me change the color. Let us assume this also part of the MST. So already MST there, right? I am thinking that this also part of MST. When I written like this one, when I draw this line, immediately you got to know cycle is there. It is a spanning tree, it is the minimum cost spanning tree. Already necessary edges are there. If I add this edge also, guarantee cycle will come. In the MST, cycle is not allowed. So without this one cycle, by adding this one, cycle is came. Some people are asking, if cycle is coming, sir, cycle is coming, we have to delete one thing. If cycle is coming, we have to delete one of the edge in the cycle, right? In the span, if you want MST, if cycle came, one of the person you have to delete in this cycle. Whom you have to delete? I want minimum cost spanning tree. So larger one I have to delete. So minimum cost spanning tree, cycle is not allowed. So we have to delete one edge, which is more. So, but if you see the problem and all, right? So I want to add this one part of MST. I cannot add because by adding this one cycle came. If by adding this one, if cycle is coming, I have to delete the larger one. But they deleted this only. Because it's not part of the MST. They deleted this only. What is the reason? The reason is in this cycle is the larger one. That is the reason they deleted. In this cycle, right, this is the larger one. That is the reason they deleted. Otherwise, he could be part of the MST. But he is not part of the MST means comparing the existing people, he is more. Some people are asking, sir, he is asking minimum possible value. Sir, he is asking the minimum possible sum of. Sir, because of he is asking minimum, right? In this cycle, larger I have to keep, it's okay. But what larger? Already existing larger is 9. You can keep 9 also here. You can, because of he is asking minimum possible sum, you can keep 9, one more 9. Some people are asking, sir, how can you keep the same 9? Can you see the problem? Is there any distinct? In the given problem, nowhere he mentioned distinct. Nowhere he mentioned distinct in the given problem. So, you can happily take this 9. Some people are asking, sir, if 2 9s are there, then why he deleted? If 2 9s are there, he can take any one. He took this one, he deleted this one. That's okay. Because of distinct not there, I can take 9 also here. In the similar way here also. In the similar way here also. By adding this one, cycle came. By adding this one, cycle is came. By adding this one, cycle is came. If cycle, by adding this one, if cycle came, then why he deleted this only? Because in this cycle is the larger. In this cycle is the larger, that is the reason he deleted. Already what is larger? 6. This also may be 6. That is the reason he deleted. Because of minimum possible value, I written the 6 here. If distinct is there, I could have written 7. If distinct is there, I could have written 7. Because of minimum and distinct not there, I utilized that facility. So you can take 6 here. In the similar way, right? I think this edge also not there in the MST. Assume it is there in the MST. Cycle came. In this cycle, who is the larger one? In this cycle, who is the larger one? I think 15. You can keep 15 here. So finally, already 36 there plus 9 plus 6 plus 15. So I think 9 plus 6 is 15, 15 plus 15 is 30, 30 plus 36, I think 66. 30 plus 36, which is going to be 66. Answer is A. Answer is A. Answer is A. Is there any problem in the sound? Is there any problem in the sound? Yeah, now maybe it's fine, right? Let's start. Let's go to next problem. To this problem, people are thinking that answer is 69. Answer is 66. Answer is 66. Not 69, 66, because distinct is not there. Because distinct is not there. Because distinct is not there. Please verify. This question may come in the exam. It will come in the exam. Please take care. This kind of question will come in the exam. So whenever some edge weights are missing, we have to find out minimum cost spanning tree. So please use the concept of cycle. Bring somehow cycle. Bring somehow cycle. Please use the concept of cycle. If this kind of problem will come, please use the concept of cycle. Please use the concept of cycle if this kind of problem will come. Distinct there, answer 69. Distinct there, answer is 69. Someone is saying, what is your take on postponing gate? Why you want to postpone? Some people studied the entire year they studied. Right? I really don't like postponing exam. It's my opinion. Maybe some people may not like. But really I don't like postponing exam. Some people struggle like anything. Right, fine, it's fine. Let's go to next problem. Let's go to next problem. Yeah, can you see this? Check. Which of the following statements are false? Which of the following statements are false? 1. For every non-deterministic Turing machine, there exists an equivalent deterministic Turing machine. 1. For every non-deterministic Turing machine, there exists an equivalent deterministic Turing machine. NTM, DTM, I think you want to say that. I think it is true. For every NTM, there exists a equivalent deterministic Turing machine. So for every NTM, there is a DTM. True, true. Both the side it is true. Go to the 2. Turing recognizable languages. Turing recognizable languages are closed under union and implement, right? Complementation. Turing recognizable languages are closed under union and complementation. Right? What is the meaning of this? What is the meaning of this? Right? Turing decidable. Turing recognizable means what? Turing decidable means REC. Turing decidable means REC. Turing decidable. Turing decidable means right, REC. Turing recognizable, that is going to be REL. Second one is REL, third one is REC. Right, let's see this one. Turing recognizable, what is the meaning? REL. This is REL. Turing recognizable languages are, means RELs are closed under union and complementation. RELs are not closed under complementation. It is wrong. Next one. Turing decidable. Decidable means REC. Turing decidable means REC. REC are closed under intersection and complementation. REC closed. So 3 is right. REC is closed. REL is not closed, but REC closed. 4. Turing recognizable languages are closed under union and intersection. This is also right. Means RELs are closed under union and intersection. True. Right? True. So I think if you observe clearly, who are wrong? Which one of the following is false? Second one is false. Only second. 2 only. Turing means RELs are closed under union complementation. No. Complementation. No. Right. So careful this. Careful. right? If you are comfortable with this, right? Let's go to anyone having doubt, let me know. Small doubt also there, let me know. So from this, please remember, see this one, please remember, closure properties, regular, right? Regular languages closure properties, CFL closure properties, DCFL closure properties. Next one, CSL is actually not required. Regular, CFL, DCFL. Next one, REC. Next one, REL. These 5 people closure properties, please learn these 5 people closure properties. You will get the definitely few questions from this. These 5 people closure properties, please learn. These 5 people closure properties, please learn. Yeah, and one more thing, see this one. This is the surprise to everyone. Republic Day special. This is the surprise to everyone. Republic Day special. 6 months free extension. That means, right? If you take 1 year subscription, 1 year or more, right? If you take the subscription, 1 year or more year subscription, if you take, right, you will get the, suppose 1 year you are taken, right, 1.6, right, 6 year, you will get the, right, subscription. 6 more months extra validity you will get. So this offer is valid from 25 to 27. 1 year and above, if you take the plus subscription, you will get 6 more months extra validity. It is valid today, tomorrow, day after tomorrow. Use code Reddy sir, right? Not only 6 months extra validity, right? If you use this code, you will get the, right, Reddy sir live. Not only 6 months validity, if you use this code, you will get the 10% discount also. Right? Do the subscription today. If those people who want to prepare for 2023 GATE exam, right, or 24 GATE exam, my sincere suggestion, use it. If you want to take, right, if you want to write 23 GATE exam or 24 GATE exam, this is the best option. Use this code, get the 10% discount also, and 6 more months extra validity also, because of Republic Day. You got this wonderful opportunity. Please use it. Now see this also. Right? So right, see this one. January 2 to January 30. So every Sunday, All India mock test is going on. Please don't miss it. Because these questions are framed by Unacademy faculty, mostly error free. 1 or 2, after all, they are also humans. 1 or 2 errors may be there, but mostly no errors. Total syllabus will be covered. Experience, actual exam like setting. Get your All India ranking. Identify areas of improvement with detailed analysis and video solutions. Enroll now. Right? So if right, those people who are not enrolled till now, scan this QR code, you can enroll. And those people who want to join in Unacademy, you can, using Unacademy Combat, you can get the maximum discount. It is a scholarship test. Using Unacademy Combat, you can get the maximum discount. Please utilize. And one more thing is, 100 lucky participants will get exciting gift vouchers also. Please use it. These are the batches on 27th Jan. These many batches are starting in Unacademy. 27th Jan, these many batches are starting for in Unacademy. So you can join in any one of the batches. CSE purpose 2024 Ascend batch is starting. 19th Jan Ascend batch is starting. Next one, right? 2023 Evalu batch is going to start. 19th Jan it is started. Foundation course also started for 23 and 24. Foundation course also started. You can join in this batch also. Right? So if in all these batches I used to teach 5 subjects. For all these batches I used to teach 5 subjects: algorithm, data structures, programming, TOC, compiler design. These 5 subjects I used to teach for all these subjects. You can join in any batch. Use the referral code. Reddies are live. Use this referral code Reddies are live to get the maximum discount. Right? Yeah. Can you go to this problem? What is the answer? Try. Yeah, let's try this. Let's try. So normally handle concept will come. Normally handles concept will come in the bottom of parser. Normally handle concept will come in the bottom of parser, right? Let's see this. Let's see. See everyone now. N star n plus n. N star n plus n. N star n plus n. So normally the concept of handles will come in the bottom of parser. You can do from bottom, that is well and good. You can do easiest way also. You can do one more easiest way also. No one will see in gate exam from top. From top in gate examination, no one will see you. So you can do whatever way you like. See, let's see one easiest way. It is actually bottom up, but you can do top down also, because in exam who will see you? Whether you are seeing from, whether you are doing from top, whether you are doing from bottom, who will see? So the easiest way is using this grammar, draw the tree first. Using the existing grammar, draw the tree first. E goes to, you have to generate this string, right? Which string? This one. Using this grammar, generate this string. Let's try how. Let's try how. E goes to E plus n. Next one, E goes to E star n. First, I think if you observe in the string, first star required, left hand side, next plus. Lastly, E replaced by n. So first create the tree. Yes, I created. After creating tree, listen, after creating tree, what you do is start from top, right? So go left side. E goes to E plus n. Go left side. Right? Start from the right stop only. E goes to E plus n. Go left side. Go left side. Go. First you have to go left. In the tree, go left side. What you do is, listen, in the tree, go left side. Left over, then only go to right. Right? Now see this one. Listen, after tree construction is over, right? So left, first go every time left, come to the bottom place. Right? See this one. This n replaced by E. This is the first reduction. N replaced by E, this is called reduction. You are replacing N by E. So first handle is N. First handle is N. Remember, first to draw the tree. In the tree, go to leftmost place. Yes, you went. So N replaced by E, this is called reduction. Right? This N is called as handle. This is the first handle. So N replaced by E, that is fine. Next one, E star N replaced by E. This is the next reduction. So next handle is E star N. Next, right? Next handle is E star N. E star N. So this cannot be answer. This cannot be answer. Answer is either A or C. B cannot be, D cannot be. Answer is either A or C. After this one is over, next handle is going to be C. E plus N replaced by E. E plus N replaced by E. Next handle E plus N. Next handle is E plus N. But see, this is the biggest mistake. This is the next handle. So overall C is the answer. 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 See this one. See this one. First handle is N. First handle is N. Next handle is E star N. Next handle is E star N. Next handle is E plus N. Draw the tree first. Draw the tree first. Draw the tree first. Umesh, you done the small mistake. Umesh, you done the small mistake. Please take care. C is the answer. C is the answer. Raju, thank you so much, Raju. Raju, thank you so much. Gaurav, you are correct. Gaurav, you are correct. Gaurav, you are correct. So to this problem, answer is C. So please take care of this. Listen everyone now. By mentioning the how many handles are there, by mentioning how many listen everyone now. How many handles? 3. Listen. How many handle? 3 handle. 3 handles are there means 3 reductions are there. Number of handles is equal to number of reductions. Number of handles. Number of handles is equal to number of reductions. That is also same. Number of handles is equal to number of reductions. See, 3 reduction. It is the first reduction, it is the second reduction, it is the third reduction, which is also called as this one, which is also called as number of handles is equal to number of reduction, which is also called as number of productions. Number of productions in the tree, which is also called as number of productions in tree. Number of handles is equal to number of reduction is equal to number of productions. Number of productions in the tree. How many productions you are using in the tree? In the tree, how many productions you are using? 3. In the tree, 3 productions you are using. In the tree, 3 productions you are using. Number of handles is equal to number of reductions is equal to number of productions. Someone is saying, sir, difference between handle and prefix production. Where you seen the prefix production? So there is no relation. Rishabh, there is no relation. See this one. This is the meaning of handle. See this one. This is the meaning of handle. See this one. A plus, careful. This is the meaning of handle. This is the meaning of handle. What is that one? See, A, B, C, A, B, C. A, B, C replaced by D. This is called handle. There is no relation, there is no linking at all. So I think if I want to say clearly, come here, you will get the idea. See this one. See everyone now. In this grammar, see this one. In this grammar, E goes to, in this grammar, E goes to E plus N. In this grammar, E goes to E plus N. So, if I replace E by E plus N, this is called as expansion. If I replace E by E plus N, this is called expansion. If I replace E, it means this side is expansion. This side is called reduction. E plus N replaced by E, that is called reduction. See this one? E plus N, you are replacing by E. This is called reduction. You are replacing this one by this. This is called handle. Only this part is called handle. This is called handle. This is called handle. See this one. This is replaced by this one. Right? This total is called reduction. This is called, right? What? Right? You are replacing this by, right? You are replacing X by Y. You are replacing X. That X is called handle. So these are handles. Normally these are handles. Right? In the grammar, whatever their right hand side, they are handles. You are replacing this by this. X. You are replacing X by Y. X is called handle. So in the grammar, whatever their right side, they are handles. These orders will be decided by in the tree from the left, right, from the bottom onwards, left onwards. You see, it is the first one, it is the second one, right, like this. Handle means subset, right? Thank you, Gaurav. Thank you so much. Right? Fine. I think it's fine. Let's go there. So remember this one. Remember the number of handles is equal to number of reductions is equal to number of productions. Right? Can you try this? Consider the following statements. 1. An unambiguous grammar has same leftmost and rightmost derivation. 2. An LL1 parser is a top-down parser. 3. LELR is more powerful than SLR. 4. An ambiguous grammar can never be LRK for any K. 5. An unambiguous grammar has the same leftmost and rightmost derivation trees. Can you try what is the answer for this problem? Five statements are given and is asking if the number of correct statements are 2 into B plus 3 into C plus 4 into D plus 5 into E, then the value of B plus C plus D plus E. Simply, indirectly they are asking how many statements are correct statements. Afterwards we will fill it. Right? Find out first of all how many correct statements. Yeah, Rishabh. Are brainless fellow Rishabh. Right? It's a viable prefix, right? Yeah, you could have said that before only. Brainless fellow. I really worried about what is this prefix production. I almost dead. Rishabh, because of you, I almost dead. I will file a case on you. I almost dead. What is this prefix notation? What is this prefix production? I almost dead. I will file a case on you. Almost I almost cried inside. Right? Fine. Right. Now let's see this one. Because of he's asking, Rishabh is asking something. Let's see this. Let's see this one. See everyone now. E plus, careful, E plus N replaced by E. So this E plus N is called as, right, this E plus N is called as handle. That's fine. E plus N replaced by E, this E plus N is called handle. This is a handle. That's okay. This is handle, it's okay. This is a handle, it's okay. Right, now listen, this handle. To this handle, whatever prefixes are there, in this handle, whatever prefixes are there, to this handle, what is the first prefix? Epsilon. What is the second prefix? E. Next to E plus. Next to E plus N. These are called vowable prefixes. Right? Set of all prefixes of handles are known as vowable prefixes. Means you are making the, see this one, you cannot get handle at a time. Slowly you have to get one by one. In the E plus N, you cannot get at a time. First epsilon, next E, next E plus, next E plus N. So this total this handle making process, right? In that process, whatever prefixes will come, they are called vowable prefixes. Handle also one of the vowable prefix. In the handle making, whatever prefixes you will see, in the handle making, whatever prefixes you will see in the stack, that is known as vowable prefixes. You are making one handle. In that making, whatever prefixes you will see in the stack, those are known as vowable prefixes. One of the vowable prefixes is a handle. One of the vowable prefixes is a handle. Right? So in the movie making, whoever you will see, because movie cannot come at a time. At a time you cannot make movie. In the movie making, you are building one by one. Those all prefixes is known as right, vowable prefixes. Movie making, right, in that process, if you see so many prefixes are there, those all prefixes are known as vowable prefixes. Movie is also one of the vowable prefix, which is also called handle. Movie is also called as, right, movie is also called as one of the vowable prefix, which is a handle. Right? Fine. Now you are okay. Perfect. Right. Yeah, can you see what the answer of this problem? Consider the following statements. 1. An unambiguous grammar has same leftmost and rightmost derivation. 2. An LL1 parser is a top-down parser. 3. So can you help in order first statement? See this one, see everyone. First and fifth is not same. First and fifth is not same because it is a derivation. It is a derivation tree. They are different. They are alag. First one and fifth one are alag. They are different. First one and fifth one is different. First one and fifth one is different because, right, an unambiguous grammar has same leftmost, rightmost derivations. Fifth one saying derivation trees. Right? Derivation trees. See this one. An unambiguous grammar has same leftmost and rightmost derivation trees. See, unambiguous grammar should contain one tree only. Unambiguous grammar contain one tree only. So, same leftmost, rightmost derivation tree. This is correct. Unambiguous grammar should contain one tree only. Tree point of view correct. Unambiguous grammar contain, right, leftmost derivation, rightmost derivation same. No. Derivations need not be same. Derivation is different. Derivation tree is different. Derivation different, derivation tree different. Please be careful. So first one is false, fifth one is true. An LL1 parser is a top-down parser. True. LALR is more powerful than SLR1. True. An ambiguous grammar can never be LRK. True. Fifth one also true. Except first one, all are true. How many are true? Can you say how many are true? Right? 4 only true. 4 only true. 4 true. Out of 5, first one is not true. Right? Remaining are true. First one is not true, remaining true. 4 people are true. 4 people are true. 4 people are true. First one is not true. Some people are saying why? See this one. Unambiguous grammar. Unambiguous grammar should contain one tree only. Unambiguous grammar contain one tree only. That is the reason it's called unambiguous, right? If you want, I can check once. See this. See this one. S goes to AB. A goes to A. B goes to B. See this one. This is the grammar. Everyone listen. This is the grammar. In this grammar, if you see leftmost derivation, this grammar, if you see leftmost derivation, see this one, leftmost derivation, S goes to AB. Now, leftmost derivation means leftmost variable you have to replace, right? That is replaced by, what is the answer? AB, right? After leftmost variable is over, next leftmost, what is the answer? AB. It is the leftmost derivation. Let's see the rightmost derivation. See the rightmost derivation. S goes to AB, right? So, which is going to be AB. Rightmost variable you have to replace. Replaced by AB. This is the rightmost derivation. If you observe the leftmost derivation, rightmost derivation, if you see the derivation, see these two are same. These two are same. These two are also same, but these two are not same. Leftmost derivation, rightmost derivation need not be same. See, here not same. Here not same. Remaining places same. Remaining places same. Leftmost derivation, rightmost derivation, even though this grammar is unambiguous because only one, right? This grammar is unambiguous because only one string, that is also one tree possible. This grammar is actually unambiguous grammar. But unambiguous grammar doesn't mean that leftmost derivation, rightmost derivation same. See, they differ somewhere. It is the small a, capital B, it is the capital A, small b, they differ somewhere. Derivation, see, unambiguous grammar, leftmost derivation, rightmost derivation need not be same, but derivation trees are same. See the derivation. S goes to AB, S goes to AB, see, leftmost derivation tree, leftmost derivation tree, leftmost derivation tree. S goes to AB, A goes to, see, first I am replacing leftmost variable. Afterwards I am replacing rightmost variable. It is the leftmost derivation tree. Now see the rightmost derivation tree. S goes to AB. First I am replacing right one. Next one is the left one. See, at the end of the day, both the trees are same. Both the trees are same. If the grammar is unambiguous grammar, derivation trees are one only. See, same. But derivations need not be same. Derivations need not be same. Very less people know this one. That is the reason I framed this question. That is the reason I framed this question. Very less people can give answer for this. Number of reduction is in RMD or reverse RMD is same. You do anyway, number of reductions are same. So except first one, remaining all are true. Except first one, remaining all are true. Leftmost derivation tree, rightmost derivation tree same because grammar is unambiguous, but derivations need not be same. Very less people know this fact. So remember to this problem. Remember to this problem. Remember to this problem. Right? Except first one, remaining all are true. So 4 people, see, if the number of correct statements are, 4. So this should give 4. This should give 4. So what should I take so that 4 will come? This should give 4. So how to select? How to select so that it will come 4? I think D is 1. D 1. I think B 0, C 0. I think E 0. D 1. So finally I think answer is going to be, what is the answer? This is 0, this is 0, D 1, this is 0, right? Answer is going to be 1. Total sum is 1. Total sum is 1. Yeah, can we go to next problem? Yeah, let's go to next problem. Let's go to next problem. Yeah, can you see this? What is the answer? So I will read once. In an adjacency list representation of undirected complete graph G is equal to V comma E, each edge UV has two adjacency list entries, V in the adjacency list of U and U in the adjacency list of V. These are called twins of each other. A twin pointer is a pointer from an adjacency list entry to its twin. If E is equal to M and V is equal to N and the memory size is not a constraint, what is the time complexity of most efficient algorithm to set the twin pointer in each of the adjacency list? In an adjacency list representation of undirected complete graph. Undirected complete graph. See, I think this is the major keyword. Undirected complete graph. Graph is complete graph. Adjacency list representation of undirected complete graph. GV comma E. Each edge UV has two adjacency list entries. V in the adjacency list of U, U in the adjacency list of V. These are called twins of each other. A twin pointer is a pointer from an adjacency list entry to its twin. If E is equal to M and V is equal to N and the memory size is not a constraint, what is the time complexity of most efficient algorithm to set the twin pointer in each entry in each adjacency list? So I think to this one I explained many times in the class, many times in the normal lectures also I explained this one, many times I done. So suppose assume that in the graph assume that adjacency, right, undirected graph, this is the graph, A adjacent is B. If A adjacent is B, suppose it is the A, B, C, D, E, F, assume, right? So right, A adjacent is B, so what you do is A adjacent is B, right, B purpose create one node. A adjacent is B, B purpose create one node. Now whenever you design undirected graph, A adjacent is B means B adjacent A also, right? So whenever A to B edge there, A adjacent B means B adjacent also A. So see this one, A adjacent is B, create one B node. In the B also, B adjacent A, create one node for A. So at a time, A in the A, B purpose create one node. In the B, A purpose create one node. After creating both the nodes, create both at a time. After creating both the nodes, what you do is, right, in the B, right, in the A adjacency list B, right, A adjacency list B, right, So keep these two nodes address each other. What does that mean? Here you keep 2000, here you keep 1000. So because, right, this A pointing to its twin, this is called twin pointer. This is called twin pointer. If at all two people are adjacent, listen, if two people are adjacent in the undirected graph, in the adjacency list representation, what you are doing is, in the A adjacent you are keeping the B node, B adjacent also you are keeping A node. These two are called twins of each other. Now in the given adjacency list, right, twin pointer you have to set to how much time? That is the question what they are asking. I am repeating once again. In the given undirected graph, A adjacent to B means B adjacent also A. When you are representing this undirected graph in the adjacency list representation, A adjacency list B there, B adjacency list also A there. These are called twins of each other. You have to maintain twin pointer. What is the meaning? In the A adjacency list B, you keep the B adjacency list A. So like this. See, A adjacency list B node address 1000, B adjacency list A node address is 2000. So in the B keep 2000, in the A keep 1000. So these are called twin pointer. So in the adjacency list for every node you have to do like this. Whatever normal adjacency list is there, same adjacency list, go to every node, keep the twin pointer like this. But remember, while creating a node, create both the twins at a time. Otherwise, if you create one twin now, if you create another twin after some time, to find out where is he and all, it will take a lot of time. If you want to decrease the time, what the best idea is? Create the twins at a time, so that linking easy. If two people are, right, suppose assume that, right, two kids came at a time. They are twins. I think linking becomes so simple. Suppose one kid is came now, after 25 years one more kid is came. I think linking both of them very difficult. One kid is came now, one more kid is came after 25 years. Linking both of them very difficult. Suppose twins came at a time, linking so easy. You can simply say, every day when you are going to school, both the people right, keep the hands one by one and go. Because both are brother, right? Both the brothers can go like this. Because both are same age group at a time came. So my suggestion is create both the twins at a time, so that linking becomes so simple. See, one more thing I will give. Listen, one more thing I will give. A adjacent is C also. What is the meaning? If A adjacent also C means, in the A adjacency list C will come. In the C adjacency list also A will come. If A and C are adjacent, right, undirected graph, A adjacent, right, A adjacent is C came, C adjacent also A came. Create these two people at a time. This is 3000 assume, this is 4000 assume, right? After creating both the nodes at a time using malloc, right, in the 4000 store 3000, in the 3000 store 4000. If you do this, linking becomes so simple. So if you can create both the twins at a time, linking become very simple. So one scan is enough. Total adjacency list, one time do scanning. Just to do one time scanning. Because after making the twin, after linking, you don't go again, not required also. If you go many times again and again, lot of time, one time only going. If you want, you can check. A adjacent is B, B adjacent is A. After keeping twin pointer, I don't go inside. Next one, A adjacent is C, C adjacent is A. After linking, I don't touch at all. So one scan is enough. One scan means how much time? Everyone know. One scan means in the adjacency list too, I think how many edges are there? Let's see. Yeah, I think M edges and N vertices. M edges and N vertices. One scan will take M plus N. Time complexity of this program is going to be M plus N time. M plus N. One scan is required. Now come here. M plus N. M is the number of edges. M is the number of edges. V is the number of vertices. M and N. Time complexity M plus N. time complexity m plus n, careful. But one thing, it is a complete graph. It is a complete graph. You only say in the complete graph, how many edges are there? It is a complete graph. In the complete graph, how many edges are there? Number of edges he mentioned m. Number of edges how many? Number of edges are going to be, right, v square, means n square. Complete graph, he mentioned complete graph. Please be careful. If at all complete graph, m and n, which is bigger? M bigger. If it is a complete graph, right, m and n, who is bigger? M bigger. M bigger means number of edges bigger. So I think option, this also correct. This is not correct. Right, mn means I think it has become more. I think this also correct. M plus n, m bigger. I think this also correct because m value n square only. M value n square only. I think first one fail, second one also, third one also fail. I think 2, 4, 5. Number of statements which are correct is 3. 3 people correct. 3 correct. It is a complete graph. See, complete graph. In the complete graph, comparing edges and vertices, edges more. In the complete graph, comparing edges and vertices, edges more, because edges are v square. Edges are v square. That is the reason. So answer is m plus n. M plus n also correct, right? M also correct. M is nothing but n square because a complete graph. 3 people correct. 3 people correct. 3 people correct. If you don't create twins at a time, to find out my twin, I should take a lot of time. I have to do lot of scanning. If both came at a time, you no need to find out. If both will come, right, different times they came, finding becomes very difficult. Where is my twin? I have to do lot of work. At a time came, right? This is the twist in this problem. In this problem, twist is, are you creating twins at a time or not? If you create different times, finding becomes difficult, then time complexity more. Sahil came. What is the twin pointer? This is the twin pointer. See this one. In the given undirected graph, A and B are adjacent. What is the meaning? If you see the adjacency list too, in the A adjacency list you will see B. If A and B are adjacent, A adjacency list you will see B. B adjacency list also you will see A. A adjacency list you will see B. B adjacency list also you will see A. These are called twins. What is the meaning of twin pointer? Right? This twin is, right? This person twin is this person. So inside B you keep the his twin address. What is his twin address? 2000 keep here. Right? Inside this person keep his twin address 1000. This is called twin pointer. Suppose assume that we two are adjacent. Then we both are called twins of each other. What is the meaning of twin pointer? At you, my address there. At me, your address is there. That is called as twin pointers. Yeah, if adjacency matrix, this problem not given. Rishabh, adjacency matrix, this problem will not be given. There is no fun in the problem. Right? Adjacency matrix, no fun in this problem. This problem having fun because of adjacency list only. After gate exam is over, Rishabh, after gate exam is over, you can try for adjacency matrix. Right? After gate exam is over, you can try adjacency matrix. Don't try before. Right? Fine. So Gaurav, if you have still doubt, see the definition. See the definition. See this one. In an adjacency list representation of undirected graph, undirected complete graph G, each edge UV has two adjacency list entries. V in the adjacency list of U and U in the adjacency list of A. See this one. Each edge AB. In the A adjacency list B there, in the B adjacency list A there. These two are called twins of each other. Assume his address is 1000, his address is 2000. 2000 contain 1000, 1000 contain 2000. That is called twin pointers you are storing. You have my address, I have your address, then we both are called twins of each other because we both are edge in the graph. Every edge of the graph will be stored inside the adjacency list. A adjacency B will be there, B adjacency A will be there. Those A and B are called twins of each other. A contain B address, B contain A address. That is called twin pointer. Someone is saying, what is the use of pointer in real life coding? In real life coding, what is the use of pointer in real life coding? I don't know all these things. United Emotion. His name is United Emotion. His name is United Emotion. He is asking this question. I don't know what is the use of a real life, that particular one. In GATE exam, 5 marks will come. In GATE exam, 5 marks will come. In GATE exam, 5 marks will come. You see, United Emotion, his name is United Emotion, right? He is asking this question. So I don't know really what is the use of in real life. In GATE exam, 5 marks will come. Less than 5 will not come. 5 marks will come in the GATE exam. Pakka 5 will come. Right? Fine. Perfect. Perfect. I think yeah, I'm stopping now. In the next class we will see. Tomorrow's class we will see some more problem. Tomorrow's class we'll see few more problems. Right? Tomorrow's class we'll see few more problems. Thanks everyone. Thanks. Someone saying application of pointers. Right, so using pointers only, right, using pointers only, accessing becomes very easy. You can access the data wherever you want. Right, total, I think tree chapter, if you see, total trees based on the pointers only. Right, total trees are based on the pointers only, if you observe clearly. Right, total, I think the dynamic kind of behavior. Right, fine, that's okay, that's okay. You can Google it out, you will get some more data. You can Google it. The problem with the pointers is maybe security issues may come. Security issues may come, right? But using pointers, all these trees and all, pointers only. Array also pointers only. Array also, see, in the array if you say, in the array random access possible. How? This is the reason only. In the array random access possible, this reason only. AI. So star A plus I. So this is the pointer. Random access possible normally because of pointers only. Anyhow, you can Google it out, you will get some more data.